In this episode, we're going to be taking a look at Istio. From my perspective, Istio lowers the barrier of entry for many advanced traffic management, security, and telemetry features. We'll chat about what Istio is, what Envoy Proxies are, what a service mesh is, and then we'll take a look at a few demos. Alright, so let's dive in. The Istio documentation is pretty good at explaining what Istio is once you sort of understand the landscape. I've been thinking about how to explain this in simple terms for a while, and I finally came up with a few diagrams and some example problem scenarios. So let's walk through that. Let's quickly set the stage by recapping what we chatted about in episode 56, where we walked through container orchestration with Kubernetes. I think a fairly easy way to understand what Istio is to see where it fits into the larger picture. I sort of think of this production stack as a set of layers. At the bottom here, you have your server nodes, either sitting in the cloud or maybe on bare metal machines. Next, you're going to install the Kubernetes master and worker node software onto these server nodes. Finally, working our way up the stack, you're going to have your containerized applications sitting at the top here. So at a high level, this covers the server side of things, but what about the software side? Well, let's say you're an enterprise type company and you have four main ways customers can interact with your infrastructure: through a mobile site, through your website, through a support site, and maybe you have a reward site. None of these systems are talking to each other, and each has their own database, and it's really ticking your customers off because they can't log into your website and see their purchase history, maybe their rewards, or maybe their support tickets, as this data is spread out in a bunch of different places. For example, I worked with a major enterprise company where they had something like this happening and wanted to consolidate all this data into a single place. This turned out to be a big problem both for customers, but also the enterprise company. When someone called the support line, support staff had to look up in a bunch of different databases and try to figure out the current state for this customer. Since this customer data was spread across a bunch of different databases, they couldn't easily mine this data for interesting trends. This actually happens quite often at larger companies, as they're often acquiring smaller companies and then they try to merge their data into theirs. I'm sure you can even think of examples at companies maybe you've worked at or maybe that you're working at right now. All right, so let's say this enterprise company has some big internal program where they're doing tech modernization, and they want to merge all of these user databases into a single master instance and have everything else call this via a user API, which will have a single entry point to the user's database. Let's fast forward into the future and say that project was successful. Now that everything's in a single place, they can now add advanced features like maybe a fraud API where they can flag suspicious trends across all customers. In case you didn't notice, we just created a real-world microservices infrastructure. By the way, I totally don't think you should adopt microservices unless you absolutely have to, as it really drives up complexity. All right, so we have our new architecture, and it's accepting traffic from the outside world into our four websites. For legacy reasons, each of these front-end services is actually written in a different language. We have Node, Java, Python, and PHP. Oh yeah, don't forget we wrote our new APIs using the Go programming language since we wanted it to be pretty performant. We've now created a total operations headache as it's super hard to get consistent tooling across all these different services since they're all written in different languages. Lots of times these enterprise companies don't even have software developers working for them that know this code. They probably hired external contractors to plan and execute this project. So the contractors wrote it in whatever language they were familiar with. I know what you're thinking, what the heck does any of this have to do with Istio? And I'm getting there, I promise. I just want to set the stage with an example problem. All right, so this example company is still going through this technology transformation, and they want to add a bunch of custom traffic routing. Maybe they want to do A/B testing, or maybe they just want to redirect users from the website to the mobile site, or maybe they want to do rate limiting. A lot of times it doesn't even need to be this complex. They just want to collect consistent logging and monitoring data across all these various services. The issues that a lot of these companies face is that since they're using different programming languages, it's hard to get a consistent view, as some of these languages likely have really good support for the tooling they're using, and some lack support at all. So they're likely seeing patches of really good stuff and really bad stuff, and there's no consistency. So they're constantly adding tons of logic into these services directly to try to make it consistent. Imagine building custom rate limiting in PHP, then in Python, and then in Java. It'd be a total waste as you're duplicating all this. What about request debugging? Say, for example, that a request comes in via the mobile site and hits the user's API. Then it makes a request over the fraud API and finally returns the result back to the user. But maybe the fraud API was really overloaded while that request came in, and the request actually was hung up for 25 seconds before it completed. how can you actually debug this request and tell what systems it touched and how long it took? And then you multiply that capability across all of your infrastructure. You can see this becomes a pain really quickly. You might be thinking no company uses all these different programming languages, but imagine a company with something like 50,000 employees across the globe. You might have a lot of different IT teams, and each is responsible for one of these services. All of a sudden, you could easily picture each of these teams wanting to do their own thing in their own programming languages. Then you have some sort of global operations team that's responsible for core infrastructure and security. The scope of this problem is way different than, say, a few developers working on some side project, or maybe what a smaller startup might face. What about security? Say, for example, that someone is attacking your support site that normally accesses the user API via a restricted username and password. The support site typically only has limited access to user data. However, they're successful in breaking into the support site, and then they're able to leverage this to break into another service, the website. For a lot of companies, once you break in through the outer firewall, you pretty much have an easy time going from service to service. Now that they have access to the website, maybe there's a less restricted username and password that they can access the database with, and they start downloading your entire customer database. So, how do we configure policies like this at the network level that says, hey, the support site is only allowed to access the user API service, and let's block any connections that go anywhere else? This would also work if we tried to connect directly from the support site to, say, the fraud API and download data. How can we block that too? So I painted a pretty bleak picture here of an enterprise corporation that has a whole bunch of problems they need to work on. And this is where Istio comes in. Istio can actually help with all of these things. So let me explain how. All right, so let's flip back to the Kubernetes side of things for a minute. So on this side of things, I see Istio sort of fitting in the picture here, sandwiched between the Kubernetes cluster and your containerized applications. Istio runs many services on the Kubernetes cluster itself, and your applications can seamlessly take advantage of it. Let's flip back to the application side of things and see how the architecture changes when we introduce Istio to this example. All right, so as I mentioned earlier, Istio lowers the barrier of entry for many of these advanced features, things like traffic management, security, and telemetry. Istio is designed to solve the exact problems we've been chatting about. This almost seems like magic, as how could it possibly do this across all these languages? The way Istio works with Kubernetes is that Istio will inject a sidecar traffic proxy called Envoy into each containerized application you're running. The Envoy proxy will intercept all incoming and outgoing traffic from your applications, no matter the language. You can think of Envoy as a layer 4 and layer 7 proxy, so it's pretty smart. So the implication of this is that instead of your applications talking to each other directly, communication is now flowing through all these proxies, like this. This is all totally seamless to your applications too. They don't even know that traffic is being captured and redirected like this. Also, external traffic from the internet is not flowing to these applications directly anymore. We're now capturing all this external traffic and making it flow through this Envoy proxy. This is the core idea that enables this Istio magic. Now that we have these direct proxies in place, we can do all sorts of advanced stuff with the applications that they don't even know about. You could redirect mobile traffic based on some user agent HTTP header right at the proxy before it even arrives at your application. For me, one of the really cool things about this architecture is now these Envoy proxies are capturing tons of metrics about requests, latency, who it's talking to, etc. You now have a complete map of what all your services are doing. So that covers monitoring, but what about our rate limit use case? Well, we can program the Envoy proxy to limit requests based on some metric that we define. You all of a sudden have this really advanced layer that your applications are sitting on top of, called a service mesh, giving you tons of advanced features across all of your web services that you didn't even have to write any custom code into your applications for. This is sort of the fundamental idea of what Istio is built for. I wanted to apologize that this example is so verbose, but you'll often find people explaining emerging technologies without really giving context of why someone would actually use this thing. So I wanted to focus on the use cases and sort of explain the pain people are going through and why they seek these types of tools out. All right, so let's chat about how a sidecar injection works. So say you're running your application on Kubernetes without Istio. This is your mobile app, and you're receiving tons of traffic here. You have a pretty smart application as it has to deal with logging, monitoring, debugging, all your security needs, etc. This can be really hard to get right across all your different services in the company, especially if they're built across different teams. So let's look at the same example, but on Kubernetes running Istio. You configure Istio to silently inject containers into your pod. Basically, you want to run multiple containers that need to work together in a single pod. like a co-located process. This pattern is often called a sidecar container. So you tell Istio to inject this Envoy Proxy sidecar container into any given pod in a Kubernetes namespace, or simply have it run in the default namespace. There's an init script that gets run when this pod is first started. This will configure IP tables rules to capture all traffic in and out of your application and make it flow seamlessly through this Envoy sidecar proxy container. This is the magic that sort of makes it work, and your application doesn't even know it's there. Since the Envoy proxy is seeing all the traffic in and out of your application, now we can do cool things with it. This also allows you to strip out complex logic from your applications that we're now handling with the Envoy proxy. So you can almost think of it like making your application thinner or dumber in a way. Istio can now grab lots of metrics and monitoring data about traffic that it sees. Same goes for security. We can now specifically say, this application is only allowed to talk to that application and block anything else. I already mentioned how we can rate limit requests. You can also use Istio to pass custom HTTP headers to your application to support use cases like distributed tracing or debugging. You can also do all types of traffic routing now too. Like, hey, I want to send 20% of my traffic to this version of the app and 80% to that version of the app. So this is how it works sort of under the hood. This Envoy proxy uses sidecar injection, and you get all these cool capabilities almost for free. So let's chat about the Envoy proxy for a minute. This Envoy proxy is an open source tool different from Istio, even though Istio uses it. So you can almost think of Envoy as this really cool tool that Istio programs to do cool things. But we'll chat about that in a minute. Envoy is an open source project written by Lyft, and they're using it everywhere in their infrastructure. It's also written in C++ and is designed to handle tons of traffic quickly. Obviously, you're paying a performance price here, since this proxy is acting as a middleman for your traffic. But oftentimes the price is small and the benefit you're getting really justifies it. There's actually a really good deep dive on the Envoy proxy in this YouTube video. I highly recommend checking it out if you're interested in playing around with Envoy or Istio. So that's one use case in that Lyft is using it everywhere, but Reddit also mentioned how they're using Envoy too. They even wrote a nice blog post about it that has some architecture diagrams. The Reddit post goes into a few of the examples that I already highlighted as why a company might want to use a tool like this. Even if you just look at metrics and monitoring alone, it's often worth it. Then you can slowly add more rules as needed. Alright, so let's flip back to the diagram for a minute. I'll add all these links in the episode notes below so that you can check them out too. The main takeaway here is that Istio and Envoy are different projects, even though Istio packages Envoy with the installer to make it easy to use. Personally, I consider Envoy really battle-tested since you have these massive companies using it. And I think of Istio sort of as the programmer or manager of all these Envoy proxies. Actually, the Istio project defines these Envoy proxies as the data plane, and Istio as the control plane, because Istio is the programmer. Alright, so why is Lyft and Reddit not using Istio itself? Well, Istio was sort of invented because a lot of these larger companies often write highly tailored custom code specifically meant for their environment. So to me, the Istio project is sort of meant as an open source controller that lots of different companies can use. At least that's my take on it. Alright, so now that we have the Envoy proxy sitting in front of all of our example applications, it's trivial to get logging, monitoring, and metrics data out of them. This is now in a single format across all our services without us doing much work. What about more advanced things? Well, this is where you'd use the control plane or Istio to take over. You can tell Istio by way of a YAML config file what you want it to do for each of these Envoy proxies. Say, for example, that you wanted to go through each of these proxies and program it with a rate limit, that you can only talk to other approved services that you know about. So now if someone breaks into our support application and they try to connect to the fraud API, we'll have the Envoy proxy automatically block the connection since it wasn't approved to talk to this other service. You might be thinking, why not just use IP tables rules here? Well, oftentimes in a container environment, things are moving really quickly, and you'll have new versions of software rolling out all the time. You'll be scaling up and down various containers. In this environment, it's way easier to have the proxy say, what services am I allowed to talk to versus getting all the IP addresses and port numbers yourself and trying to sync that manually. So to me, this pattern actually offers some real operational benefits too. Alright, hopefully all this makes sense. I wanted to go through and sort of lay the foundation by giving you some solid examples and then a bunch of diagrams to support the use cases. Alright, so now let's check out the Istio documentation. They actually have really good technical pages with lots of examples and some good introduction stuff too. This page is great as an introductory to Istio, as it talks about what Istio is, at a high level, what a service mesh is, and basically talks about how Envoy proxies work. So here's a pretty good architecture diagram of what Istio is. You have all this control plane stuff down here. Pilot is used to program the Envoy proxies. Then you have the mixer here for monitoring and policy enforcement. Say, for example, that service A wants to talk to service B. It would check in with the mixer and make sure that's allowed. Sort of a warning here is that policy enforcement has a performance impact as you're doing these checks live, but there's lots of caching happening too. Actually, there's this really good talk called Life of a Packet through Istio that explains all this stuff in super great detail. It's about 2.5 hours long and it walks you through all this stuff at a network level. It's well worth watching if you're actually planning on implementing Istio in production. Then there's Citadel. This allows encrypted pipes between the Envoy proxies, basically encrypting all traffic within your service mesh, even though your applications might be talking in plain text. Then you can sort of see here that the Istio control plane is programming and chatting with the Envoy proxies all the time. One really cool thing about the website is this tasks section here. Talks about stuff like traffic management, like load splitting, traffic monitoring, fault injection, etc. Then you can check out security with lots of different stuff in here around authentication and authorization, etc. By the way, all of these are sort of labs that you can go through. Then down here you have the policy section. There's a lot of stuff about how you can write rules for things like rate limiting, etc. Finally, you get into the telemetry section where you can do cool things like monitoring, logging, distributed tracing, and all that cool stuff. So let's go back to the example in the traffic management section. Let's choose something like traffic shaping. This example allows you to split load between a couple different services. Say, for example, that you wanted to do a canary deployment of some new version of software. You want to deploy only a small fraction of live traffic to this new instance to see how it holds up. You can use this YAML config file here to split traffic 50-50, say between version 1 and version 3 of your application. I think there was actually a really good diagram of this under the concept section here in the traffic management document. Yeah, if we scroll down a little, there's a good example that actually sort of highlights the concept of what we're talking about. All right, so you can see we define a rule via this YAML file, and we ask the Istio pilot process to go and program the correct Envoy proxies with this rule. Then the proxies will go and distribute this traffic like we asked. So let's back up for a minute. So we're looking at this Istio diagram that explains the Istio control plane. Basically, the server code Istio uses to take our configuration from us. Then it keeps an eye on all these Envoy proxies and pushes out new configs. So all these services, the pilot, the mixer, Citadel, etc., are all running on Kubernetes inside containers. Let's take a look at that layered diagram again. So we have Kubernetes, then Istio, then all our applications sitting above it. Actually, let me update this with the Envoy proxy here too. So you have the Envoy proxies here, seamlessly being injected as sidecar containers into your application, and then you have Istio and all its services running on Kubernetes. As you'll see in the demo in a minute, Istio can actually be programmed right from the kubectl command as it augments the Kubernetes API. So this is why I see it almost like an extension of Kubernetes when I'm using it. So this diagram basically sums up my mental model of how I think things work. And you can sort of envision how requests are flowing from one layer to the next as you're using this architecture. All right, so that's enough theory. Let's actually install a Kubernetes cluster with Istio and then run some examples. I'll add a few more episodes on this topic running through more complex architectures, but I wanted to get some foundational stuff down before doing that. If you have any suggestions on what you'd like to see, please let me know. As we looked at back in episode 56, Google Cloud allows you to easily spin up a Kubernetes cluster, but they also added this new beta feature, which allows you to install Istio on the cluster too. This is pretty awesome in that you can install a test cluster like this in about 5 minutes and have it up and running and run through your demos. So it's really easy if you want to follow along too. So I'm logged into the console here, and I'm going to go up to this hamburger menu icon and select Kubernetes engine. Then we'll select Create Cluster. I'm going to call this episode 63 testing. And we'll put the cluster in US1A since that's close to me. A 3-node cluster should be okay. Next, we'll click this advanced option down here, and we'll scroll all the way to the bottom and check this Enable Istio Beta checkbox. Then let's create it. So I'm just going to pause the video here as it takes about 5 minutes for this to get set up. And I'll come back once the install is complete. All right, so we're back and our Kubernetes cluster is created with Istio installed on it. So how can we actually verify that? Well, let's click on the cluster here. You can see basic stuff like our cluster, the version, the nodes, etc. But if we scroll down under this add-ons section, you can see that Istio is enabled. But since Istio is also running its services on the Kubernetes cluster, you can also verify that it's running and healthy too. You can do that by clicking over to the Workloads tab. You can see we have a whole slew of Istio containers running. Things like Citadel, Pilot, our sidecar injection service. This sort of speaks back to the layered stack diagram I was showing earlier. So let's deploy an example application and walk through the splitting traffic example, where we want half our requests to go to one version and the other half to go to a different version. So let's head back to the cluster information page and click this connect button. This will open up a command prompt and authenticate us against this new cluster, basically so we can run commands. All right, so we're authenticated now. You can read the docs about this, and I'll add a link in the episode notes below, but we need to turn on Istio to inject our sidecar containers. This is turned off by default, so I need to enable it for a particular namespace. This is just an example cluster, so it doesn't really matter, but if you wanted to test this on an existing cluster, you'd probably need something else here. Personally, I'd recommend always creating a test cluster when you're playing around with stuff like this, because you could easily blow things up. All right, so let's deploy two versions of the same application and create a service for them. One with version 1 and the other with version 2. I've added a bunch of code up to GitHub. This includes the YAML files, the source code for our demo app, and you can access this all via the GitHub link or the Docker Hub links in the episode notes below. You can check these out. All the demo app does is it prints out its version number, either version 0.1 or version 0.2. But this will work great for our traffic splitting demo as we can see what's going on. So what we're doing is deploying two versions of our application and putting a service in front of them with a cluster IP. So I've cloned all the YAML files from my GitHub into the shell here. So let's apply the first YAML file that will deploy our example applications. You'll notice in the YAML file here that I never mentioned anything about Istio, Envoy, or anything like that. Let's verify these pods were actually created by running kubectl get pods. Great, it looks like it worked. But how can we see if this Envoy sidecar container was actually injected by Istio? Well, we can run kubectl describe pod and then the pod name at the command line here. Then if you scroll up here, you can see references to the sidecar container here. Then we have our init scripts. This is where the init script is configuring IP tables rules to intercept all traffic going in and out of this container and pipe it over to our Envoy proxy. This goes back to the diagram here, where we inject our sidecar container and then seamlessly intercept all traffic without our application even knowing about it. Then if we scroll down, you can see the co-located containers running in the pod. We have the demo application that I created, and then this Istio proxy one, which is the Envoy. Pretty cool, right? It just seamlessly plugs in and we can do cool stuff for free. So this is probably all we need to check out to prove that it's working. All right, so let's move on to our second script here. This script creates an Istio gateway for accepting external traffic from the internet on the Istio ingress gateway and routes it into our cluster. I guess the way to explain this is that everything we've done so far is within the Kubernetes cluster, and hey, we need a way to route external traffic off the internet into our cluster. Next, we're going to create a Istio virtual service. This will sort of bridge the gap between our demo app instance and the Istio gateway. So we're routing traffic from the internet through Istio and into our demo containers. Since we're piping the traffic through Istio, now we can program it to do cool stuff. So let's jump over to the console and apply this YAML config file to set up this gateway. All right, so the Istio gateway was configured. Now let's get the ingress IP by running this command. So this is our external address here. Let's open that up in a browser and see what it says. Great, you can see it says version 1 and then version 2. These are our two demo instances that we created earlier. Even though we're not doing anything fancy here, I still think this proves out the end-to-end system, in that we fired up our example containers, we configured Istio with the Envoy proxy to intercept the traffic. Now we're using a web browser that's transversing all these layers. So let's jump back to the command line and write a little for loop to make calls to our application using the curl command and give us a count. So you can see 10 requests here. Then let's pipe this through the sort command. And then let's count these up using unique-c. You can see we have an even split here. I've actually used this technique quite a bit where we pipe data to sort and then use the unique command to count it. You can actually check out episode 28 where I walk through a workflow. Kind of a useful trick to use when you're looking at a lot of log files or you want to do this type of stuff. All right, so let's say that we only wanted to send a portion of the traffic to version 2 of our application. Well, in the third YAML script here, I've created this destination rule that sort of breaks out our demo applications into two groups, one group for version 1 and a second group for version 2. Then we'll tell this virtual server down here that we want to send 80% of the traffic to group 1 and the other 20% to version 2. So let's jump back to the console and apply this rule. So let's run our curl loop again and see what it did. All right, looks like it's mostly working as we get a larger number from version 1 than version 2. Let's bump up the request to 100 and see what that looks like. Great, looks like our weighted traffic rule is actually working. And it's totally happening seamlessly from our application. It doesn't even know anything special is happening here. All right, in the fourth and final example, I'm basically doing the same thing, but I'm shifting 95% of the traffic to version 2 and 5% to version 1. So let's apply that script. Then let's run the for loop again to see what the results are. Pretty cool, right? And it's fast too. We just applied the rule and then we can do our load test and it works. So this is a good proof of concept, but you can use this as a starting point to sort of explore what these rules can do. If you head back to the Istio documentation, you'll find tons of examples in here. All sorts of traffic management, security, etc. stuff. Maybe try rate limiting on your own. Or maybe try throwing errors for a percentage of traffic. This can be really useful for trying to test how a system will react when things are going badly. Well, this pretty much wraps things up. But I wanted to mention that right now I think of Istio as sort of an early adopter technology without too many companies using it, at least publicly. But it's quickly gaining traction, and I suspect over the next couple conference cycles you'll see a lot more companies talking about this publicly. I wanted to do an episode on this as it's sort of more of a cool look as something that's kind of emerging versus something that you should run out and implement today. All right, that's it for this episode. Thanks for watching, and I'll see you next week. Bye.